All right, 9.3. I'm recording nonlinear systems of equations. All right, so nonlinear means it's not straight lines. So if we wanted to solve this system, what kind of shape is that? What kind of shape? Really?
It's non-linear.
Are we just tired because it's a Monday, or do we not know that that is a circle?
I didn't.
Wait, what? Oh.
Probably both.
Yeah, that's a. I thought circles were
Okay, so I'm glad that somebody's awake. That is not a circle. That is a potato. It's not a potato either. It's a parabola. So that's a parabola. This is a cubic because it has x cubed. Remember, cubics look like this potentially. So we're supposed to graph them on a calculator and find the points of intersection. Okay? We're using our calculator still. We're trying to find where those two equations intersect. So go ahead and grab your calculator. Enter those two equations into your calculator. It should intersect in 3 spots according to my notes here. So I'll give you a second to give it a try. Make sure you're back in function mode. You don't need to be parametrics or polar. And pause. Alright, so I'm going to function, and we're not using a matrix right now, we're just using our graphs. Oops.
Okay.
So go to y equals x squared minus 2x plus 2.
Oh, there it is.
I am in function. That's nice.
Then we have x cubed plus 2x squared. So once you have them graphed, okay, I'm going to do a zoom standard. There's my parabola. Yeah, I need to, maybe it'll see it now. Alright, so we've got a cubic and we've got a parabola. Looks like it intersects right here, intersects here, and it probably intersects again up there. So you might want to do one, well, you got to do one at a time. So you could find that intersection point. Remember, to find intersection point, you have to calculate. Maybe I'll zoom in first. I'm zooming in on that point right there. So a lot of the work on these types of problems is just manipulating your calculator to find the solution. So I'm going to find that point intersection by going calculate. Now what? Do you remember? Intersect. Very good. It asks for the first curve. It's already on the blue curve. I mean, you can move it if you want. I'm just going to hit enter. The second curve. Should be the red one, and guess, hit enter, and it tells the point of intersection. 2.23 comma 2.52. There's my one out of 3. That was the easy one. Now you're gonna have to like zoom standard, zoom in, and manipulate your window to find the other two. I'll give you a few minutes. Did we all get another or the other two? You did? Okay. So I'll do one more. I'm going to do zoom standard, and I'll do the one that's not on the screen. There's my parabola. Here comes my cubic. Don't make me, okay, there it is. So I'm going to go up and to the left a little bit. So my window, I'm going to adjust my Y max. I'm going to make 15. My X min, I'm going to go negative 15. Should be on the screen now. Again, there's my parabola. And here comes my cubic. Don't make a liar of me. There it is. Alright, so I'm going to zoom in right here.
It's magic.
And then we can calculate the intersection. First curve, second, too far away, and there's my other intersection. Okay? So it's nice when your equations are in y equals form. This bottom one is an example of a hyperbola and an ellipse, or a potato. And they are not in y form, so you need to solve for y. You actually have to do some old school algebra to get y by itself. So we subtract 4x squared, divide by 9, and then take the square root. And it's both the positive and the negative. So it's the top half and the bottom half. When you do a square root, make sure you do plus and minus. Same thing here, solving for y, we have to get, I moved the y squared to the right, moved the 25 to the left, then did a square root. Okay? Do you see what I'm doing with those? Why is there no solution?
Because they don't intersect.
Because they don't intersect. Very good. Is it possible that a parabola and a cubic, like we did up here, is it possible that you could have a parabola and a cubic that never intersect? Think about that.
Because I don't think they continue. At one point they have to.
No, it's not possible.
I don't know. That's a tough one. Like if I have a parabola that looks like this, and I have a cubic that's like that, it looks like they wouldn't intersect.
At a very, very
This
long
one's-
point, it'll connect up here.
Yeah, because the cubic is increasing faster than the parabola. At some point they would probably intersect,
Probably
yeah.
like 2000 or something.
But that would be an evil problem if I had to do that. All right. So, story problem. It's a true story problem. It's a problem I had, well, a scenario I had. I have a built-in cabinet in my basement, and it is 44 inches across. I think that's, yeah, 44 inches wide. So I have a built-in cabinet. I'm trying to figure out, can I get a 46-inch TV into that spot? 46 inches means
Diagonally.
diagonally. Very good. So if a TV is 46 inches, that means that diagonally this is 46 inches. Did you know that?
Yep.
Okay. So in HD TVs are in a ratio of 16 to 9. That also is true. So this could be 32, this would be 18, this could be 16, that could be 9, or anything on the whole spectrum. But it's always the ratio of 16 to 9. That's what HD is. It used to be, anybody know what it used to be?
4x3.
4x3, almost square. Good. The old TVs are 4x3. These are 16 by 9. Kind of fit the movie theater screen. Okay, so the question is, will a 46-inch TV fit my 44-inch wide cabinet?
Yeah.
So we have two scenarios. We have one scenario that we know that if it's in 16 by 9 form, we don't know how wide it is and how tall it is, but we know that it's similar shape to 16 by 9. So we can set up an equation relating those variables. We know it has to fit that criteria, that it has to be 16 by 9 ratio. The other scenario is that it has to be 46 inches across. We're trying to see if how wide a 46-inch TV is. Okay, so if this is 46, again, we don't know what that x is and that y is. But how are these x's and y's related? Well, x squared plus y squared is equal to 46 squared. If you think back to geometry, you could say 9 is to 16 as y is to x. You could also do 9 is to y as 16 to x, or 16 is to 9 as x is to y. All of those form a proportion, and you can solve for y. So I have two equations. I've got one that it has to be in the 16 by 9. That gives me that equation. And I have the other scenario that the hypotenuse has to be 46 inches. And we're trying to find the width of that TV. X squared plus y squared equals 46. Okay, so right now, y equals 9 over 16x, and we have x squared plus y squared equals 46 squared. I want you to solve that system. You can use your calculator and find how wide is the camera. I'll give you a couple minutes to do that. Okay, the first one I already did for you. It's already solved for y. That you can enter in the calculator. This one you're going to have to solve for y and find the intersection point of the both curves. All right, again, so this is already in y equals form. This one has to be put into y form in order to put input it into the calculator. So I'm going to move the x squared over. So y squared equals 46 squared minus x squared. And then you can do square root. So plus or minus the square root of 46 squared minus x squared.
All underneath.
All right, so we have 3 equations. We have this one,
I just square root it immediately.
the positive one, and the negative one. So y equals 9/16 x square root of 46 squared minus x squared, and the negative square root of 46 squared minus x squared. And we could graph it, and we've got some manipulating to do again. So there is my line, and we need to find the intersection of our sideways parabola, because it's a positive and negative square root, and it's nowhere to be found. So what do I have to do? How do I find it? Well, trace, you're just going to move along. I don't know if that would work. It may work. How do I find these 2 equations on our calculator screen?
Do 2 separate ones.
Well, they're already entered in. How do we see them?
Zoom out.
Good. Zoom out. That was more difficult than it should have been. Oh, I saw something.
What? Is that the parabola? Is that a circle?
Zoom out again. All right, so we are looking for the x value. Remember, x represents the width of my cabinet. It would not make sense for x to be negative. So as Ethan said, let's just focus on the positive intersection point. So I'm going to zoom in at that point right here, and that's going to be my x value. Okay, we want to know the x at that point right there. You can see the positive and the negative. So I'm going to calculate the intersection. Yes, we want the line to be 1, and we want the positive top one to be 1. And then we're going to guess it to be right here. And I get 40.09. So my cabinet is, no, the TV is 40.09 if it's 46 inches across. So does it fit in my cabinet? Do you remember how wide my cabinet is?
Yes.
44 inches wide. Does it fit? Yes? That's assuming what? If you go buy a TV that's 46 inches
That's assuming
across.
the bezel is 0.
It has what?
0 bezel.
0 bezel?
The little black part that goes around the screen.
Is that what that's called? It's got a
Yeah.
name?
Yeah.
Yeah, I call it a frame, but it's got a TV frame is a bezel.
Yeah.
Good. That's exactly right. So we need to know how big the bezel is. We know that the screen's going to fit, so when we go buy the TV, look at the one on the display, we pull out our little ruler and see this better be under 4 inches in order for it to fit inside my cabinet. Um,
22.5.
22.55.